Good day to you, students. How are you doing? We are here once again to present to you chapter 6.4, dealing with energy calculations. Let's do it together. So, for us to be able to see how energy is calculated, let's drag the following words into the correct boxes. If an object is lifted off, a force is needed to increase its gravitational potential energy. Gravitational potential energy is also known as potential energy anyway. Gravitational potential energy is calculated by multiplying the weight of an object by its height. So we check. That's correct. Let's move on. Now, gravitational potential energy. Before calculating a body's gravitational potential energy, ensure that A, the vertical height through which the body moves is calculated. B, consider the change in the height of the object's center of gravity. Now, we are to deal with this activity and provide the answer. An athlete of mass 50 kilogram runs up a hill. The foot of the hill is 400 meters above sea level. The summit is 1,200 meters above sea level. By how much does the athlete gravitational potential energy increase? All what you just need to do is this. What is the formula associated with gravitational potential energy? Let's just write it that Gp is equal to weight times height. Then we have weight simplified to be mass times acceleration due to gravity times the height. Don't forget that we have a difference in height. Let's say the first height, 1 is what? 400 meters. Seventh height is what? 1,200 meters. With that, we now have a change in height, or the difference in height. That would be 1,200 minus 400, still in meters. So change in height is equivalent to 800 meters. So instead of having h alone, I can then have delta h, that is change in height. So my gravitational potential energy now becomes, what is the mass we were given? 50 kilogram times gravity, as you can see, 10 meters per second squared, times height, 800 meters. So Gp now is equal to 50 times 10, that's 500, times 800 meters. So Gp, at first, we have 5 times 8, that is 40. Then you take the remaining zeros with it. How many? 1, 2, 3, 4. 1, 2, 3, 4. So here now we have 400,000 watts. Gravitational potential energy is measured in joules. And don't forget that 1,000 joules is equal to what? 1 kilojoule. So with this now, I'll have it to be what? 400 kilojoule. Do we have it? So let's pick and check. That's correct. So let's move on to the next slide. Now, we are dealing with kinetic energy. Now, it takes energy to make things move. A moving object is a store of energy. This energy is known as kinetic energy. The kinetic energy of an object depends on two main factors. These are the object's mass, represented with m, the object's speed, represented with v. This is combined in the formula KE is representing kinetic energy is equal to half times mass times speed. I mean the square of the speed is equal to half mv squared. So we have to deal with this activity and get the result. Okay, so let's read out the question and solve it. A van of mass 2,000 kilograms is traveling at 10 meters per second. We have to calculate its kinetic energy. If its speed increases by 20 meters per second, by how much does its kinetic energy increase? Don't forget that here now we have initial velocity and the increase in velocity now, which we can use a denotation for final velocity for, which is 20 meters per second. The initial is 10 meters per second. So with that, let's start. We know that the formula for kinetic energy is what? Half mv squared. So, and don't forget that we are dealing with initial velocity, which is 10 meters per second. So our mass is 2,000 kilograms. So let's see what the kinetic energy will be. That's half times 2,000 times velocity is to be squared. That's 10 squared. 10 squared will give us what? 100. So we have kinetic energy is equal to what? Half times 2,000 times 100. 2 in 2,000, that's 1,000. And don't forget that whenever you have 1,000 joule is equivalent to what? 1 kilojoule. Whenever you have 1,000 joule is equivalent to what? 1 kilojoule. I repeat. So here I can now write 100 times 1 kilojoule. So answer is now what? 100 kilojoule. That is our first answer. Now we move on to the point by which we were asked that if its speed increases by 20 meters per second, by how much does the kinetic energy increase? If you really want to calculate the increase, you will still put out that what kinetic energy is equal to what? Half m. Then the increase will now be what? In terms of what? Our delta V. That is the change. So kinetic energy now becomes half m into what? I'm making use of what? Initial and final. So for the final, I have V substitute V minus initial. You substitute what? V all squared. So this one is all squared also. So my kinetic energy now is what? Half times 2,000 times, so I have 20 minus 10 all squared. Now don't forget the rule for completing the square, times 2,000 times, that will be, if you have 20 minus 10 all squared, you can write it as 20 plus 10, 20 minus 10. So with that, kinetic energy now becomes 2 in 2,000, that's 1,000 times 30 times 10. Don't forget that I mentioned that 1,000 joule be equivalent to 1 kilojoule. So that becomes 1 kilojoule times 30 times 10, that's 300. So kinetic energy in this case, that will be 300 kilojoule. So here now, if you look at the combination of the answers we have 100 kilojoule and 300 kilojoule. So let's pick it and check whether we are right. So I have this now, that is correct. Now let's move on. A stone of weight 1 Newton, all right, falls downwards, okay? Its gravitational potential energy decreases by 100 joules. How far has it fallen? So this is what you need to do for this calculation. I have weight to be 1.0 Newton, and I have my gravitational potential energy or potential energy rather to be 100 joules. What is the formula connecting them? So I can write it as P is equal to what? Weight times height. Then if I divide both sides by height, that's divided by 8, this and this will what? Cancel out. So we are dealing with what? The calculation of height rather. So I can do it again. Divide both sides by weight. This is it. Weight times height divided by what? Weight. This and this will cancel. So height now will now be the gravitational potential energy divided by what? Weight. Height is equal to the gravitational potential energy is what? 100 joules divided by the weight is what? 1.0 newtons. So joule per newton can be expressed in what? As meters. So 100 over 1, that's 100 joule per newton, which you can now write as 100 meters. So do we have 100 meters there? So let's check and see. That is correct. So let's move on again. Okay. Another activity in a car engine. The energy stored in the fuel is converted into thermal energy, which is also known as heat energy, and energy of motion, that's kinetic energy. In which form is the energy stored in the fuel? Now, under the topic relating to the forms of energy, we made mention that what? Fuel stores what? Chemical energy. Alright? So the correct answer here will be what? Chemical energy. Let's pick and see. Correct. When an aircraft, alright, flies horizontally at a height of 9,000 meters, its gravitational potential energy increases. Now, in this case, this statement is false. When a plane is flying horizontally, okay, the gravitational potential energy does not what? Does not change due to the fact that it is maintaining a constant height. So the statement here now is false. All right, and let's check. That's correct. So before we go, let's deal with these correct statements for us to be able to identify which one is right, which one is wrong from the list of the statements rather. Now, energy is a vector quantity. No, energy is not a vector quantity because it only has magnitude without direction. A vector quantity must have magnitude and direction. Energy utilized by a person is measured in newtons. No, energy is measured in joules. So energy now is a scalar quantity, correct? Because we only need to know the magnitude or size associated with energy, which is measured in what? Joules. So let me pick it and see what the answer will be. That's correct. Energy is a scalar quantity. Now to the next set of statements. Energy stored in a fuel is kinetic energy. No, energy stored in fuel is chemical energy. That means in fuel we have a measure of chemicals that can be converted from chemical energy to what? Other forms of energy. Energy stored in a moving object is gravitational potential energy. No, that statement is false. Energy stored in an object due to its position of motion, that's gravitational potential energy. Alright? Energy stored in a moving object is kinetic energy. Correct, because for a moving object, it must have mass and what? Velocity. So let's pick it and see. Energy stored in a moving object is kinetic energy. That's correct. So with this, we've come to the end of this class. Do well to subscribe onto our website www.edubbey.com for more of our interactive notes and videos. See you next time. Bye.